Hi everyone, this is my project Skysaver. It analyzes flight prices in the US domestic market. So let me start by explaining the problem that motivated me to do this project. So anybody who has booked flights knows how frustrating the process can be. You might check a price on Monday, decide to think about it, and by Tuesday the price has increased by say $200. So airlines typically use a so-called yield management system to adjust prices sometimes even multiple times a day. So these systems consider factors like competitor pricing, how many seats are left, or even the day of the week you're searching. So for travelers, this creates an uncertainty to as to when to book and whether you're getting a fair price. To address this problem, my project aimed to answer a few questions. First, does flying farther always cost more? Second, do airlines charge more when they are the only option on the route? Third, which airlines typically have the cheapest fares? This is just to check if budget carriers are consistently cheaper on all the routes. And finally, when is the best time of the year to fly to a certain place in the cheapest way possible? So, yeah, this is just to see if there's any seasonal pattern in pricing. And for this analysis, I worked with the data set from US Department of Transportation. It consists over 250,000 individual flight records, and each record has the origin, destination, the operating carrier, distance, the price, and the passenger count, and a lot other attributes. So one of the first analysis I performed was a principal component analysis. This technique reduces the complexity of the data while retaining the important information. What I discovered was that just five main factors explain 95% of all variations. So while airline pricing seems very complex from outside, it may be influenced by a relatively small number of factors, you see. So the analysis also revealed a strong relationship between distance and fare price. However, I found that different carriers showed their own pricing strategies, and overall performing PCA allowed for a more efficient modeling. Also, later in the project, by focusing on the most influential factors alone. Next, I used clustering techniques to identify natural groupings in the flight data. And instead of finding a simple division between budget and premium pricing, I tried to analyze multiple tiers. And it turned out that the same airline might use different pricing approaches on different routes. That's really surprising. And next, it was evident that distance affected the prices. Yeah, but there was an outlier. Certain routes that are business heavy had a very unusual pricing pattern, and these are the routes where they have limited competition as well. Yeah, one interesting finding was that high volume routes they maintain a premium pricing even if the passenger count is really high. Then I performed association rule mining that did show how one is related to other, like in an instance. And it showed that very long distance flights are consistently associated with high prices, which makes sense because the operational cost might be high. And I found that low cost carriers consistently appear in association with medium market share and lower fares, regardless of the distance. And legacy carriers, they have strong association with high market share and premium fare category, particularly on routes to major hub cities. Lastly, flights to popular tourist destinations associated with seasonal fare fluctuation, and they have high competition. Moving to more predictive approaches. So I applied naive Bayes model to classify fares into different categories. The model achieved 66% accuracy. Um, it shows that the fares do follow some predictable pattern, and over here the distance remained the strongest predictor. Although the relationship isn't linear, it is still the strongest predictor. And very long routes had more variable pricing. Oh yeah, Southwest Airlines in particular was the most predictable. And on some routes where one airline mostly dominates, ticket prices are actually lower. Moving on to decision tree analysis, this had an accuracy of nearly 69%, and distance turned out to be the biggest factor, as already stated. The model could spot different price ranges for short, medium, and long flights. Each airline seemed to have its own way of setting prices, and you can see that clearly in the decision tree. Then, on performing linear regression analysis, I found something really interesting about the structure of the airline pricing. So, there appears to be a base fare of approximately $170 that applies regardless of the distance. So, over the $170 is added 7 cents per miles traveled, like the route distance. So, however, distance alone explains about one third of the variation in fare prices, and other factors like competition, the demand, seasonality, or just their strategy influences the remaining two thirds. So, yeah, no wonder it feels so predictable, because distance, which is the most visible factor to us, only explains a relatively small portion of the fare. Moving on to logistic regression, this showed how likely it is to get uh, high fare based on how far you're flying. So, for short trips under 500 miles, high fares are pretty rare, since those flights are usually priced to compete. And but for longer trips over 1500 miles, the high fares are pretty much likely, because more cost to run that far, and usually less competition. And what's really interesting is the middle range, the flights between 750 and 1250 miles, where the chance of a high fare goes up very quickly. So this seems to be a key area where airlines change up their pricing strategies. So this is the most advanced or complex model I used amongst the other, which was support vector machine, and it did really well. It reached 95.5% accuracy when using nonlinear kernels. So this huge jump in performance compared to the simpler models probably tells that the flight pricing is complex, but it still follows some pattern that smart algorithms can figure out, maybe. Yeah, so one of the most interesting findings from the SVM was how market share connects to pricing. So, what would we think that if one airline dominates, price would go up, right? But the model shows it's more complicated. In some cases, a high market share actually means lower price. Maybe because the airline is cutting cost, or just pricing it strategically to stay on the top. Never know, but yeah, a lot of new insights. I also tried out ensemble methods like random forest, and gradient boosting, which combine a bunch of models to get better results. So these methods generally did better than the single models. It just backs up what I found earlier about the distance and all the other results. So here as well, distance kept showing up as the biggest factor, and but market share and airline type was really important. So what's great about these ensemble method is that they can catch really tricky interactive very tricky factors, like for example how market share affects price differently depending on the flight distance or the airline. Moving on to the conclusion and wrapping up, the key insights that I got was that while distance is the biggest factor affecting the prices, it actually explains less of the price difference than most people think. So airlines use complex pricing strategies that depend on the route, market conditions, and the competition. And the next was that despite what's commonly believed, having a dominant market share doesn't always mean higher prices. And how predictable the pricing is varies a lot between each airline. So, yeah, airline prices is complicated, but it's not random. By recognizing several mold patterns and going more deep into it, we can make booking flights less confusing and more predictable. Yeah, so that's all from me. Thank you for your time.